So, good day everyone. Today, my group will be discussing about the Adams method. But before we go into the details, let me first give a short introduction about this. So, in the 1830s, John Quincy Adams noticed a problem with the apportion system used in the United States House of Representatives. So, apportionment is the process of distributing seats in a governing body among states that have the right to representation. This idea of fair distribution can also be seen in everyday aspects of life, such as dividing responsibilities in a group or sharing resources fairly in a community, because Adams believed the system at that time favored larger states, so he proposed a new approach called Adams method. This is to make the representation more balanced and fair. So now let's talk about how the Adams method works. So in this method, a revised divisor is chosen so that the total of the upper quotas will equal the exact number of seats that need to be distributed. So each calculated quota is always rounded up to the next whole number. However, rounding up does not always produce the correct total number of seats. Because of this, the divisor must be adjusted several times and recalculated until the rounded results match the exact number of seats required. This process helps ensure a fair and accurate distribution.
Moving on, I will be talking about the definition of terms. So first, we have the standard divisor. This is the total population divided by the total number of seats to be allocated. It represents the average population per seat. Second is the standard quota. This is the exact number of seats a group should ideally receive. And this is calculated by dividing the group's population by the standard divisor. And this is also often a decimal. Third is the upper quota. This is the defining feature of Adams' method. The standard quota is always rounded up to the nearest whole number. And fourth is the modified divisor, and this is a new divisor found through trial and error, which is usually larger than the standard divisor, and it is used when the initial rounding result is too many seats being assigned. And lastly is the modified quota, and this is a group's population divided by the modified divisor. That will be all. Thank you.
So now let's move on to the steps or procedures of Adams method. Step 1 is compute the standard divisor. So for you to compute this, you need the formula total population divided by the total seats. So think of this as finding the total cost of one single seat. You take the total population of all the states combined and divided by the total number of seats you have available. Step 2 is compute each state's standard quota. So this tells you exactly how many seats each state deserves based on its size. You take each state's individual population and divide it by the cost you found in step 1. So this usually results in a decimal like 5.1 or 6.7. So step 3 is initial rounding. In this method, you always round up to the next whole number, like for example 5.1 becomes 6 and 6.7 becomes 7. So the catch to this is that because everyone is rounding up, you will almost always end up with a total number of seats that is higher than the actual number of seats you have to give away. Next step is choose a modified divisor. Because rounding up usually results in too many seats being assigned, we pick a new, larger divisor to bring the total down. So making the divisor larger makes the seat more expensive in terms of population. So next step is round each modified quota up. You repeat the math from step 2, but this time you use your new larger modified divisor. So after you get your new decimal numbers for each state, you round them all up to the next whole number again. Last step is adjust divisor iteratively. So we keep adjusting that divisor up or down until the total number of seats matches our goal exactly. So if the total is still too high, pick an even larger divisor. And if the total is now too low, pick a slightly smaller divisor. And if the total matches your seat count, you are finished. And these are your final results. So that's it. Thank you.
Good day everyone. Today I will present two sample problems using Adams method. So for problem 1, we need to apportion 12 seats among 4 states, A, B, C, and D, which each state has a different population. First, we try using a divisor of 90,000. After dividing the population and rounding up, the total number of seats become 13, which is too many. Next, we adjust the divisor to 100,000. After dividing and rounding up again, the total number of seats becomes 12, which matches the required number of seats. Therefore, the final apportionment is State A receives 5 seats, State B receives 4 seats, State C receives 2 seats, and State D receives 1 seat. Now, let us move on to problem 2, where we need to apportion 7 seats among 3 parties, the X, Y, and Z based on their votes. First, we try a divisor of 800. After dividing the votes and rounding up, the total number of seats becomes 9, which is too many. So we increase the divisor to 900. After recalculating, the total number of seats becomes 7, which is the correct number. Therefore, the final apportionment is Party X receives 4 seats, Party Y receives 2 seats, and Party Z receives 1 seat. So in conclusion, Adams method ensures that each group receives seats proportionally by adjusting the divisor and rounding the quotas upward until the required number of seats is obtained. Thank you for listening.
Good day, everyone. So, today I am assigned to the solutions from problem 1 and problem 2. And today we'll walk through how to apply Adams method for apportionment using 2 sample problems. Adams method works by calculating quotas with a divisor, rounding all quotas up, and adjusting the divisor if the total seats don't match our target. So let's get started. So first up, we need to apportion 12 seats to states A, B, C, and D with the given populations. So let's start with our initial divisor attempt and problem 1. So problem 1, initial attempt divisor is equal to 90,000. So state A, we have 420,000 is divided by 90,000, approximately equal to 4.667, right arrow, 5 seats, rounded up. In state B, we have 350,000 divided by 90,000 is approximately equal to 3.889, right arrow, 4 seats, rounded up. In state C, we have 180,000 is divided by 90,000 is equal to 2, right arrow, we have 2 seats, rounded up. In state D, we have 120,000 is divided by 90,000 is approximately equal to 1.333. So right arrow, we have 2 seats, rounded up. So note that 13 is greater than 12, which is the target. So the divisor is too small, so we need to increase it. So using a divisor of 90,000, we divide each state of population by the divisor to get the quota. then round up every single one. Adding them up gives 13 seats. That's more than our target of 12. So we'll try a larger divisor, 100,000. So in second attempt, we have the divisor of 100,000. So state A, we have 420,000 is divided by 100,000 is equal to 4.2. Then right arrow, which give us 5 seats, then 5 seats rounded up. And state B, we have 350,000 is divided by 100,000 is equal to 3.5. Then right arrow, we have 4 seats rounded up. In state C, we have 180,000 is divided by 100,000 equal to 1.8. Then right arrow, we have 2 seats rounded up. And lastly, we have state D, 120,000 is divided by 100,000 equal to 1.2. Then right arrow, we have 1 seat, then rounded up. So the total seats is equal 5 plus 4 plus 2 plus 1 is equals 12. So this matches our target of 12 seats. So our final answer for problem 1 is state A is equals 5, state B is equals 4, state C is equal 2, and state D is equals 1. So now with the divisor of 100,000, recalculating the quotas and rounding up give us 5, 4, 2, and 1 seats. So adding those gives exactly 12. So perfect. So that's our final apportionment for problem 1. Next, in problem 2, let's apportion 7 seats to parties X, Y, and Z based on their votes. Again, we'll start with an initial divisor and adjust as needed. So our initial attempt in problem 2, we have the divisor of 800. So party X, we have 3,200 is divided by 800 equal to 4. The right arrow, we have 4 seats rounded up. And party Y, we have 2,100. This divided by 800 equals 2.625. Right arrow, so we have 3 seats rounded up. And lastly, we have party Z, we have 1,200 is divided by 800 is equal to 1.5. Then right arrow, so we have 2 seats rounded up. So the total seats 4 plus 3 plus 2 is equal to 9. So note that 9 is greater than 7, which is the target. So divisor is too small, so we need to increase it. So starting with the divisor with 800, dividing each party's votes by the divisor, rounding up every quota gives a total of 9 seats. Way over our target of 7. So we'll increase the divisor to 900 and try again. So in our second attempt, we have the divisor is equal to 900. So party X, 3,200 is divided by 900 is approximately equal to 3.556. Right arrow, we have 4 seats rounded up. Then in party Y, we have 2,100 is divided by 900 is approximately equal to 2.333. Then right arrow, we have 3 seats, then rounded up. So lastly, we have the party Z. We have 1,200 is divided by 900 is approximately equal to 1.333. Right arrow, we have 2 seats, then rounded up. So the total seats is 4 plus 3 plus 2 plus is equal to 7. So this matches our target of 7 seats. So our final answer for problem 2 is party X is equals to 4, party Y is equals to 3, and party Z is equals to 2. So with divisor 900, the new quotas rounded up are 4, 3, and 2 seats. Adding them gives exactly 7. That's exactly what we need. So that's our final apportionment for problem 2.
Using the Adams method in problem 1, the divisor must be adjusted until the total number of seats matches the required number. When the divisor 90,000 was used, the total seats became 13, which is more than the required 12 seats, meaning the divisor is too small. After increasing the divisor to 100,000, the computed seats for states A, B, and C, and D became 5, 4, 2, and 1, giving a total of 12 seats, which matches the required number. Therefore, the correct apportionment is A equals 5, B equals 4, C equals 2, and D equals 1. In the second example, using the Adams method, the divisor 800 is resulted in a total of 9 seats, which is more than the required 7 seats. So the divisor is again too small. Increasing the divisor to 900 produced the seat allocation of X equals 4, Y equals 3, and Z equals 2. But when applying Adams rounding up, the correct total becomes 7 seats. Thus, the final seat distribution is party X equals 4, party Y equals 3, party Z equals 2, which satisfies the required number of seats.
So in conclusion, Adams' method of apportionment is a tool used for allocating seats in the United States House of Representatives, basing them on their population in a systematic and fair approach. This includes adjusting the standard quota by rounding it upwards to make sure there are no groups underrepresented, and to ensure the population is proportional in order to determine the final number of seats that each state receives. Adams' method of apportionment is important because it serves a mathematical approach to fairness in dividing representatives, specifically by prioritizing the representation of smaller states or parties. This ensures that no states are underrepresented by quoting the lower quota bias that often favors the larger states. Here are the following references used.